Now, in order to find the variance of the distribution, first we have to find the value of k, and also we know that maximum probability is 1. So the probable values are given in the table. So sum of these values must be 1 plus k by 2 plus k by 6 must be equals to 1. If I simplify, then the value of k will be 1. Now we know the formula of variance v of x is nothing but e of x square minus e of x, which is mean, whole square. Now in order to find the variance, first we have to find e of x square as well as e of x whole square. To find that, let us make a table of x, then p of x, x into p of x, and x square into p of x. The values of x are minus 3, minus 2, 0, 2 and 3. Let us go for the sum here. Now the p of x values is nothing but 1 by 12. Just multiplying this k by 6 to this minus 3. Next value will be 3 by 12, then 4 by 12, then it is 1 by 12, and sum is nothing but 3, 7, 8, 9. So 1 by 12, 3 by 12, 4 by 12, 3 by 12. There is one more thing which is 3 by 12, which is missing out. Minus 3, minus 2, 0, then 2, 3. And if I add them, it will be, this is 1 by 12, this is 3 by 12. Sum will be 1. And similarly, x into p of x, minus 3 by 12, minus 6 by 12, 0, 6 by 12, 3 by 12. If I add this, sum is nothing but 0. Similarly, x square into p of x, 9 by 12, 12 by 12, 0, 12 by 12, 9 by 12, and 42 by 12 will be nothing but their sum. Now, v of x is nothing but 3.5 minus 0, because the mean is nothing but 0, which is nothing but 3.5. So the option is C.
Linear voltage regulator circuit is shown below. Calculate the minimum value of the load resistance required to maintain the output voltage constant. Okay, according to the data, the Zener diode must be operated in the breakdown region in order to get the constant output. Means V0 should be 20 volts always. So V0 is 20, which is nothing but 30 divided by 20 plus RL into RL. So 3RL is 40 plus 2RL. So RL is 40 ohms, which is option B is correct. Find the number of 2 input NAND gates required to implement the following Boolean function. Here, if we simplify this expression, A bar B 1 plus CD plus BC bar 1 plus D bar and this is one more plus D, okay, plus BC. This is A bar B, BC bar plus BC. Here A bar B plus B C plus C bar, this is 1. So B 1 plus A bar, that is B. So after simplifying Boolean expression F, we will get B. That is B letter is already available. There is no implement two input using 2 input NAND gates. Okay. Hence option A is correct. After executing the following 8085 program, what are the status of the flags? Okay. Means we have to check the last instruction, that is ORAC. See how doesn't affect the flags at all. So ORAC, that is O-ring accumulator with a C, is the arithmetic instruction or logical instruction which affects the flags. So accumulator contains the contents of B, that is 91H, and C contains A8H. So O-ring of these two numbers, that is 101001. Okay, this is 1010 1000 A8H. So O-ring of 10 is 1 0 0 1 1 1 0 1. So carry flag is 0, 0 flag is 0, sign flag is, that is MSB bit is 1. So option D is correct.
The eigenvector of the matrix 3 2 1 0 4 2 0 0 2. Now it's clearly upper triangular matrix. So the eigenvalues are nothing but 3, 4 and 2. Now by taking these eigenvalues we can form the equation. The equation will be nothing but x1 plus 2x2 plus x3 is equals to 0, which is 1, and 2x2 is equals to minus 2 times of x3, that is equals to 0. That implies x3 is equals to minus x2. It is nothing but 2x2 plus, actually this is equals to 0, which implies x2 is equals to minus x3. Now if I take the equation 1 and simplify, x1 is minus x2, and if x2 is equals to minus 1, x3 will be obviously 0, so x1 will be 1. So the eigenvector will be nothing but 1, minus 1 and 1, which is nothing but option A.
Output of a multiplexer shown below is, see, A can take two values, that is 0, 1. We have to look at expression y. So if A is 0, the y is I0 is selected, I0 line is selected, I0 is further connected to A, means output is 0. If A is 1, I1 is passed to the y, that is 1 is connected to I1, hence y is 1. So y is nothing but A, hence option C is correct.
Differentiate the function y is equals to x bar x plus x bar 1 by x. Now we cannot differentiate this x bar x and x bar 1 by x directly, so I'll convert them into two different functions. I'll take x bar x as y1 and x bar 1 by x as y2, and I'll apply logarithm. Logarithm of y1 is x log x here, and logarithm of y2 is nothing but 1 by x log x, and I'll apply UV rule, that is product rule, and differentiate this, and I'll obtain the value of dy1 by dx as y into x bar x into 1 plus log x. Similarly, dy2 by dx is nothing but x bar 1 by x square into 1 minus log x, and their sum, which is differentiation of y, will be x bar x into 1 plus log x plus x bar 1 by x into 1 minus log x by x square, which is nothing but option A. Now we have to find the area of the rectangle bounded by the curves x is equals to 0, x is equals to A, y is equals to 0, y is equals to B, and a vector f x square plus y square times of I minus 2xy times of j over C f dot dr. Now we know that over C f dot dr is nothing but double integration or surface integral of del cross f dot n times of ds. N is nothing but the unit vector here. Now del cross f, if I calculate, it will be k times of minus 2y, which is equals to minus 4k y or 4y k. Now when you del cross f dot n into ds, which is nothing but minus 4yk into dy dz times of I plus dz dx times of j plus dz dx dy times of k, and if I simplify, it will be minus 4y times of dx dy. Now let us find this integral now. Integral f dot dr, which is nothing but over the region minus 4y dx dy, and the regions are, we know the regions here, 0 to a if it is x and 0 to b if it is y, dy dx. If I simplify, it will be minus 2a b square, which is nothing but option D.